coordination compound.
Okay.
So basically coordination compound, which is basically combination of different salts, that is called coordination compound. But there is a condition in coordination compound. Basically we have a addition compound, and first we are going to classify this addition compound. Different salts combine to form a compound that is known as addition compound, and this addition compound is divided into two parts. The first is double salts, and the second is complex compound, or CPD stand for compound. Okay.
Okay.
Okay, and this is your coordination. Now what is the difference between these two? So it's very simple. As you can see, this double salt is basically is the one, if you are going to dissolve it in a solvent, it will be completely dissociated into its ions. So
Okay.
we can also write which lose their identity in solution. If you are going to dissolve it in a solvent, it will be completely dissociated. As for example, let's take an example, FeSO4 dot NH4 whole twice dot SO4 dot 6H2O. If you are going to dissolve it in a solvent, it will be completely dissociated and it will lose its identity. Are you getting my point?
Yeah.
It will have different properties now because all are in their ionic form. But
Okay.
this retain its identity even in solution. Okay.
Yeah.
So if you have a compound, complex compound, K2CO CN whole 4 Cl2, this. So if you are going to dissolve this elements or anything, species that present outside the bracket will be dissociated into ions, but inside bracket it won't be dissociated. It will be as it is, like this. Is
Okay.
that clear? So the addition compound which retain its identity even in solution, that is complex compound, and which does not retain its identity, that is called double salt. Okay.
Yeah.
Okay, so moving to the some terms that is very important, some terms, and that is very important. So first of all, I'm just going to write the name and then I will explain. So we have coordination entity. Another term that we use is coordination sphere. Another term that we use is central atom. And then comes ligand. And then comes coordination number. And then comes counter ion. So there are some terms that is very important. These terms we need to be focused on. So if I'm taking the example of the previous complex compound, that was like this, right?
Yeah.
I just forgot to write Cl2. So I am taking this example. So always remember, outside bracket or outside bracket, whether it is in left hand side or right hand side, are known as basically your counter ion. These are known as
Counter.
counter
Okay.
ion. Coordination entity, that all the species that present inside the bracket, that is called coordination entity. Coordination
Okay.
entity. And this part is known as basically coordination sphere. This part is known as coordination sphere.
Okay.
Okay, coordination sphere.
Wait, both coordination entity and sphere are same.
Yeah, these all. This is coordination sphere. Sphere is like just the surface you can see. These are all. This is coordination sphere.
And entity
Okay.
also the same.
What you just said.
Yeah, coordination entity also is like the
Yeah.
same.
Coordination sphere is the space that we can call, and coordination entity, that is the atom and all things that is present.
Okay.
Okay. Now come to the next point, which is your central atom. So after just bracket, the left hand bracket, this is your central atom.
Okay.
And except central atom, all the species are known as ligands.
Okay.
Okay. Then comes to the counter ion that I already explained. I already this explained, this explained, this explained this. What is the coordination number? So basically, number of bonds, or we can call it coordinate bond. Here, basically coordinate bond forms. Number of coordinate bonds between central metal atom and ligand, that is called coordination.
Okay.
Here, right now, the coordination number is 6, because this CN makes one CN makes one bond, so 4 CN make 4 bond, chlorine make 1 bond, so 2 chlorine makes 2 bond, total bonds is 6.
Oh, okay.
So that's why. Okay, is that clear?
Wait, number of bonds between CMA stands for central, okay, metal
Metal
atom.
atom, or you can say central metal ion.
Okay.
Okay, so this
Yeah.
is your basically the basic terms that we will use and you can easily understand, right?
Yeah, yeah.
Now ligands are very important, that we will discuss later, how many types of ligands are there and what it is. Okay,
Okay.
now this complex compound or coordination compound are divided into two parts. One is homolaptic and another is heterolaptic. So see, it's very easy to understand. Homolaptic, that means a central atom which is surrounded by same ligands, and which is surrounded by different ligands or more than one ligands, more than one different ligands. Are you getting my point?
Yeah.
I'm going to take an example. If you are going to write the example of this as K3 CO CN whole 6, you can see only one type of ligand is there. So that's
Oh,
why, yeah, it will be visible.
okay.
Can you see the screen?
Wait. Yeah, yes.
So CN6, you can see only one type of ligand is there. That's why it is homolaptic. And for heterolaptic, I can take an example of CONH3 whole 4 and then Cl2. This is, you can see, two types of ligand are there. That's why it is heterolaptic complex.
Yeah. Okay.
Okay.
Yes.
It's very important to remember some of the ligands on the basis of charge, like to find it will be very helpful to calculate the oxidation state, because without oxidation state, the nomenclature will be incomplete. Okay,
Yeah.
so NH3 is neutral, H2O is also neutral, and this, if you have like this 1,2 di methane diamine, that is also neutral. These are all neutral, or
Okay.
methylamine is also neutral. Okay, these are
Yeah.
all neutral ligands. There are some ligands that you need to take care of, like Cl is -1. You know that hydroxide has -1.
Yes.
Oxalate, that is C2O4 -2, that represents it has oxidation state -2. SO4, you
Yeah.
know that from your childhood, it will have -2.
-2.
Yes or no?
Yes, yes.
So I'm going to give some questions to calculate the oxidation state of central atom. Calculate oxidation state of central metal atom. And sometimes it will be written as central metal atom or ion. Can I change the slide?
Yeah, yes.
Okay. Now see, I'm gonna give some question. You just need to calculate it. CONH3 whole 6 raised to the power +3 CONH3, whole 6 Cl3. Third is K4Fe, CN, whole 6. Fourth is K2PD, Cl4. Fifth is COCl2, En whole twice, raised to the power plus. Then comes K3Al, C2O4, whole thrice. HJ, CO, SCN, whole 4. NiCO, whole 4. PT, NH3Cl, NH2CH3, Cl. Always remember one more thing,
Yeah.
Davis, that if something is written before bracket, that will be positive counter ion, and something is written after bracket, that is negative counter ion. You already know what is counter ion, that is before bracket, after bracket, yes or
Yeah.
no?
Yeah. Yeah.
So before bracket, you can say it will be always metal, that is
Yeah.
positive, okay, and after bracket it will be generally non-metal or ion, some that is negative ion, anion.
Okay. Okay. Yeah. Yeah. Good. Cyanide has what oxidation state?
Cyanide ion.
Yeah. Yeah. CN. Yeah.
Cn, have you seen Cn anywhere? What is the charge on that? Cyanide ion, Cn minus.
Okay. Minus. So minus one.
That
Okay.
is basically your nucleophile, a strong nucleophile it is.
Yeah. Yeah.
If you have studied that chapter, aldehyde and ketones, do you remember
Yeah.
uh,
Yes.
nucleophilic addition reaction in which we react aldehyde or ketone with hydrogen cyanide? With hydrogen cyanide, the reaction is slow
Yes.
because
Yes.
hydrogen
Yeah.
cyanide is not that much a strong nucleophile. So we convert it into cyanide ion to make a strong nucleophile.
Yeah. Yeah. Wait, SCN will have what charge?
Thiocyanide.
Yeah, thiocyanate.
SCN minus it
Minus.
will be.
Okay. Yeah, for first one I got 3.
This will have +3. This will
Yeah,
also
plus
have
3.
+3. This will have +2. This will have +2. This will have +3. This will have 3 to the 6 +3. This will have +3. This will have 0. This will have 1, 2, +2. Is there any that is wrong?
Wait, checking. Yeah, seventh and eighth one I got wrong. Can sir show that?
Seventh, Hg exists in +1 oxidation state.
Okay.
Did you take +2?
Yeah, I took plus 2.
Actually, there is a variation.
Oh, okay.
That depends on the central atom's stability. Are you getting my point?
Okay.
So you
Okay,
have
okay.
to remember it for a while. Okay.
Yeah, yeah.
So that's why +1, and you know that -4 that will go be to be +3.
Yes, yes. Okay.
And as you can see, CO is neutral ligand.
Oh, it's okay, okay. Okay.
Okay, so that's why.
Yeah, yeah. Yeah, done.
Then can we move to the next part?
Yes, yes.
Okay, so this was about oxidation state. Now going to classify the ligand. So it's a very important to write the list of ligand, you know,
Okay.
classification of ligand. And we are going to classify this ligand on two base. There are two base on which we are going to classify the ligand. So the first one is on the basis of charge. On the basis of charge, we are going to classify it. As you can see, there is three types of charge. We can say cation, cationic ligand, and then anionic ligand, and the one which does not have any charge, that is neutral ligand. Are you getting my point?
Okay.
So as you have seen that during the uh, oxidation of central atom, you have some ligand which does not have charge. As for example, I can take example of NH3. Okay, what did you
Yeah.
take of this En? I didn't ask you. I was about to ask.
Yeah,
What is
EN is
this?
0, right?
Why? What is this En stand
I
for?
Yeah, I think diamine,
Yes, yes,
ethylene
it is 1
diamine. Yeah.
comma 2 diamine. So
Yes.
amine is there, so it's 0. Very good.
Okay.
So NH3, or you can call it En, or H2O, or CO. When you will do a lot of question, you will have You will come to know there are a lot of ligands that is neutral in nature. Then come to the anionic. Anionic is very famous, and most of the questions are from this anionic. And
Okay.
C2O4 minus 2, and also there is a EDTA4 minus. We will see what it is. EDTA4 minus, and
Okay.
these are all basically your anionic ligand that has negative charge, and cationic ligand that is the very less that is used in our exams and everywhere.
Yeah.
NH3 positive, NH2 positive, etc. So this was the classification of ligand on the basis of charge. Now come to the classification of ligand on the basis of denticity. On the basis of denticity. Do you know what is denticity?
And no, no.
Basically, how many bonds can a ligand form? Basically, there
Okay.
are ligands that can form more than one coordinate bond. That is called denticity. Okay.
Okay.
So in short, I can define this as basically denticity is the number of coordinate bond formed by one ligand. Formed by one ligand.
Okay.
So we can divide it in monodentate, or we can write unidentate. That means it will form only one ligand. And with
Yeah.
the help of this denticity of a ligand, you can easily count the number of, you can easily calculate coordination number. Are you getting my
Okay.
point? So
Yeah. Yeah.
ligands having only single donor atom, the ligands which have only single donor atom, that is your donor site. That will be very good. Donor site, single donor site, that is monodentate, as for example Cl minus, Br minus, I minus, etc. That forms only one ligand bond. Okay.
Okay.
Then
Yeah.
comes the bidentate. Bidentate, or we can also call didentate. That means basically the ligands which form, which have two donor site, and forms two a coordinate bond, two donor sites, and forms two coordinate bonds. Okay.
Yeah.
So as for example, we can take example of this as your ethane 1 comma 2 diamine, that is CH2. I'm going to show you it has two donor sites, and then again CH2, and then NH2. As you know that nitrogen will have lone pairs, so it can donate from two sides, this nitrogen and this nitrogen. That is your En, and its IUPAC name is ethane 1 comma 2 diamine.
Okay.
Okay. Now come to the next. That is C2O4 minus 2 oxalate ion. Oxalate ion. And it's a structure. I'm going to write this double bond O, and then double bond O negative and O negative. And you know, negative, that means two electrons. So it can do this.
Yeah.
So there are more examples of this. When you will be solving questions, you will get different types of bidentate. So you are going to make a list of this monodentate, and most importantly this didentate and mm, polydentate. Okay.
Okay. Okay.
Now come to the next, that is polydentate. That means more than two, we can say
Yeah.
more than two. The donor site will be more than two, and also it's very important to note that it will form more than two coordinate bonds. So EDTA4 minus I told you. So I'm going to write the structure of this CH2, and there is CH2, and then nitrogen, and then nitrogen, then comes CH2, and then CH2, and then comes C double O, and then comes C double O, negative, negative. and then comes CH2, and then comes CH2, and then comes C double O minus, and then comes C double O minus. You can see that it is basically your hexadentate. You know why? Because it will donate from here, 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 and it can also donate from here and here. That's why it is hexadentate. Are you getting my point?
Okay, okay. Yeah,
Hexadentate, and its name is basically your ethylene diamine tetraacetate, tetraacetate ion. That's why it is called EDTA4 minus is the short form. And that's why its
okay.
coordination number equals to 6. It has 6 donor sites that comes under polydentate ligand.
Okay. Yeah.
Got it?
Yeah, I got it. Yes.
Very good. Can you change the slide?
Yes, yes, yeah.
Okay. Now come to the next point, which is the part of this denticity, and that is called ambidentate ligand. Do you know what is ambidentate ligand?
Yeah, it can donate from two sides, right? That's ambivalent.
Yeah, 2 donor
Right?
sites. So why it doesn't come under didentate,
Uh,
but will donate with one side only at a time, one side
yeah, yeah,
only
yes. Yeah, yeah, that was it. Yes.
at a time.
Yeah.
That's why it comes under a special denticity that is called ambidentate, and its example is basically NO2 minus, SCN minus, and etc. As you can see, this is negative and this is double bond, so it can donate either like this to central atom, or it can donate from oxygen to central atom. You can see there is 2 donor side, this and this, and it
Yeah.
will use only one of it. So that's why it come under a special name of denticity, that is ambidentate. We can take example of SCN. So the negative charge is here, so it can donate from here, or NCS minus. So it has lone pair, so it can donate from here, and it will have only one use at a time. That's why
Yes, yeah.
it is ambidentate ligand. I think it's clear to you, right?
Yeah, yeah, yes.
Let me know when you're done with this. Can I change the slide?
Wait, wait. Yeah, done.
Very good. Okay, let's start this rules for writing formula. Have you studied it?
Like IUPAC name?
Yeah, IUPAC of this coordination compound.
Yeah, yeah, yes, yeah,
You have studied this.
yes.
Very good. Wait a minute. I'm going to directly give you a question, then I'll see
Okay.
how to explain. So rules for writing formula, that means the name will be given. So if I'm going to give you a name, tetra amine, aqua we use for water, okay?
Yeah. Okay.
Aqua, chlorido, cobalt, 3, chloride. See, this is your complex compound, right? There will be either positive counter ion that is positive, and
Yeah.
there will be a counter ion that will be negative only, and I think only one will be present at a time, right? In a compound,
Yes.
if
Yeah.
positive will be there, negative will not be there. So
Yeah.
whenever you are going to write the name or anything, the name of this coordination entity, there will be no space between them, but between counter ion and the name of the coordination entity, there will be a space, as you can see, right?
Okay, okay. Yeah, yeah.
Please do write its uh, formula.
Yeah, okay, done.
Very good. Let me just write the formula and I will see you will check it whether you have done it correctly or not.
Yeah, yeah,
So tetraamine and first of all cobalt. So I'm gonna put cobalt here and you can see tetraamine, that means NH3 4 and
yeah,
then comes aqua, that means H2O, and after that the bracket close and chloride, that is this, right?
yeah,
Yes or no? So
yes.
if you just need to write one chlorine and then calculate the oxidation state. If you are going
Yeah,
to
3.
calculate the oxidation state, you will get only +1, right?
Wait.
According to this formula. According to this formula. Yes or no?
Oh, okay, okay.
But
Yeah,
there is 3, right?
yeah, 3.
So
Yeah.
I'm going to write 3 here. Then it will be x is equal to +3. That means it will be in +3 oxidation state. And this is your correct
Okay, okay.
correct
Yeah.
formula. And this counter ion is basically to balance the charge. Are you getting my point? Because this is
Oh,
also 0, this is also 0, right? What you had
yeah.
written,
Yes, yes.
what you had written,
Yeah,
okay?
yeah. I got, yeah, same thing. Yes, CO, NH3, 4, H2.
Did
Yes.
you get Cl3 or something else?
Yeah, CL3 only. I just looked at the formula, 3 was there. I put 3.
Because in counter ion, it won't be determined that it is tri, di, or anything. Are you getting my?
Yes.
Okay, come to this. Potassium is there. This is positive counter ion. I'm just putting K first. Then come to the this zincate, that means zinc. And tetrahydroxido OH, and tetra, that means 4. If you are going to
Yeah,
calculate the oxidation state of central atom according to this formula, you will get only +3. But we need to do +2. So I'm gonna
plus
put
2.
2 here.
Yeah.
Okay.
Okay. Yeah.
Now again potassium is there, so K. And then after trioxalate aluminum, oxalate that means C2O4, and tri it is, that means whole thrice. And you can, if you are going to calculate the oxidation state, it will be +5, right?
Yeah, yeah.
Because O3 sorry, C2O4 -2 into 3, that is -6, and +1 +5 will be there. So in order to make it 3, I'm going to take it 3, right?
Yes. Yeah.
So as you can see, there is no counter ion. So directly jump to the central atom, that is cobalt. After cobalt, there will be ligand, that is dichloro, right? So it will be
Yeah.
Cl2. And base, whenever there is complex ligand, we use bis tris tetrakis. Are you getting my point?
Okay, okay. Yeah, yeah, yeah.
So
Yes.
bis, that means twice, and then like this. And after this, there is positive sign. If you are going to calculate the oxidation state according to the formula, it will be +2 only, right?
Oh, okay, okay.
But we
Yeah.
have, there is no counter ion to balance, so we will write charges according to our need on the bracket, square bracket.
Okay, okay. Okay.
Got it?
Yeah, yeah, yeah.
Very good. This is very easy. Nickel, directly nickel, tetracarbonyl, that is CO, which is neutral
CO4.
ligand. So CO4 it is,
Yeah.
right?
Yes, yes.
Can I move to the next part?
Yeah. So whenever, so always have to calculate oxidation state, like just in case.
Yeah, you should calculate it, and you know it will not take much time. You can look
Okay.
at the formula and you can directly tell me what is the oxidation state. It calculated within second, right?
Yeah, yeah. Yes, yes.
Because
Yes.
if you will not give some of the seconds of your, then might be it will be incorrect, right?
Yeah, yeah,
Mistake is
yeah.
very necessary. Okay.
Okay.
Now I'm going to give you write the IUPAC. Okay.
Yeah.
Okay. So this is your PT, which is NH3 whole twice Cl NO2. Then comes the second, K3 Cr C2O4 whole thrice. Then comes the third, that is CO Cl2 En whole twice. Then comes the fourth, CO NH3 whole 5 CO3 and Cl. Hg CO SCN whole 4. Okay, one more thing you need to know. Did you revise the nomenclature? Yes or no? Honestly.
Yeah, yeah, yes, yeah.
Okay, then do this.
Okay. Yeah, done.
So I'm going to write the answer. Please match it. And
Yeah, yeah. Okay.
okay, its name will be basically just see. Uh, diamino, diamine, chlorido. Did you write chlorido or not?
Okay, I wrote diamino chloride.
No, no,
Wait.
diamine chlorido.
Okay, okay. When do we add the ido water?
See, not
Yeah,
I or ido. We write the name of anionic ligand. At the end
yeah.
of anionic ligand, we add O. Okay.
Okay, okay.
So we remove E chloride and add O. So it will be chlorido. NO2 has negative charge. That's why it will be nitrito, not nitrate.
Okay, okay. Yeah, yeah. I made mistake there. Yeah.
So take care of it. Whenever there is negative ligand, anionic ligand, the name ends with O.
Okay, okay.
And then platinum and whatever is the oxidation state, I think 2 will be there, right?
Yes. Yeah.
Now come to this. You have, if you have positive counter ion, that name will be written first. Potassium only, not tripotassium, not tetrapotassium. Okay.
Yes. Yeah.
Then there will be a space. Come to the ligand, and it is tri. Oxalate has negative charge, so it will be oxalato.
Yeah, yeah. Okay. Yeah.
And then come to the chromium. Okay. There is another concept which is very important to learn.
Yeah.
No, wait a minute. Okay. Come to the point. If you have, if you have negative charge on bracket, on a square bracket,
Yeah.
the name of central metal atom ends with 8. Are you getting my point?
Yes. Yes. Yeah.
So did
Yeah.
you write chromate? Yes or no?
Yeah. Yeah. Yes. I will.
Yeah,
Yeah.
yeah, that's good. Either it will
Yeah.
be directly reflecting on here, or either there, if there will be negative positive counter ion, if counter ion is here, that means indirectly there is negative charge there, right?
Yeah. Yeah.
Then
Wait,
come to this point.
wait, it's chromate 3, right?
Yeah, yeah,
How is it?
chromate 3, chromate
Okay,
3.
okay.
Yeah,
Okay.
yeah. Then again dichlorido, and since it is a uh, complex coordinate, so we use bis instead of di. 1
Yeah, yeah.
comma 2 di ethane 1 comma 2 diamine, and then
Yes.
cobalt, right?
Yeah, cobalt 3. Yeah.
And then 2 there will be, right?
Wait, I
Then come
got.
to this point,
Wait, is it?
pentamine.
Wait, how is it 2? Like,
No, no, no,
wait,
it's 3. Sorry,
yeah,
it's
3.
3.
Okay. Okay.
Yeah,
Okay.
this one and 3, 2. 3, 1 plus 2, 3,
Yeah,
right?
yeah. Yes.
Now come to the next point. This, I'm gonna tell the name, pentamine carbonato. This is carbonate, CO3 minus.
Yes. Yeah.
So the name ends with carbonato, O, right?
Yeah.
Carbonato, then cobalt, and come to be 3, and then
Yes.
cobalt 3, right? Wait a minute.
No, I got cobalt 7 in 9. Sorry, 4 to 9.
Oh, what you just said?
Yeah, I got like cobalt 7. Like,
7?
yeah, like the oxidation state is 7.
No, 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 no.
No?
You are
Okay.
going to use CO3 minus 2, no? Carbonate.
Yeah, -2. Yeah.
You are not going to deal with this, right? If you are going to deal with this CO3, just see, carbon will have X, 4 in 3 into minus 2, that will be equal to 0. So X will be equal to plus 2, right?
Wait, X.
See,
Yeah.
you are
Okay.
going to use directly CO3 minus 2, carbonate ion.
Yeah.
So minus 2 we are going to directly use.
Yes. Yeah. Okay. 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 Yeah. Yeah.
So it will be 3, right?
Yeah. Yeah, 3. 3. Yes.
Again,
Yeah.
this is your mercury.
Yeah.
1, and then come to this. Mercury 1 is very important to write because this is D block element and its valency is vary. Valency basically
Okay.
variable oxidation is exist of D block elements. That's why we do write it, right?
Okay. Okay. Yeah, I didn't write. Okay. Yeah.
Yeah. So this is now tetrathiocyaneto. Tetrathio. If S is there, that means thio, and cyaneto, cyanide was there. So cyaneto because it is negatively charged ligand, and then
Okay.
comes to the next point, and it is very important to write thiocyaneto S. That as you already know that this is ambidentate ligand, right?
Yeah. Yeah. Yeah.
So we need to specify that this SCN is connected or the donor atom is S. So we need to write S here. If the donor atom is N, then we need to, then the formula will be written NCS and we are going to write in nomenclature N, thiocyaneto N.
Okay. Okay. Yeah.
And
Yeah.
then again, it will be cobaltate, right?
Yeah.
Cobaltate and 3. Is
3.
that
Yeah.
clear?
Yes. Yes.
Okay.